Hello chemistry students. In this video I'm going to continue the stoichiometry notes with the second example, and we'll work through this. So this one asks us to calculate the mass of carbon dioxide produced by the combustion of 5.03 grams of ethane. So let's start out and set up our problem. Alright, so the unknown here is the grams of carbon dioxide. The known here is that we have 5.03 grams of ethane, and they were nice enough to give us the formula for ethane, so we don't have to try and write it. Alright, so our plan is, we start with ethane, we go to carbon dioxide, we need to convert compounds, so that is going to require a balanced chemical equation. And then we're going to go grams to moles to moles to grams. So 1, 2, 3 steps to get through this. Alright, so let's do our solve. I'm actually going to come up here and write the chemical reaction. So it tells us the reaction type, it's combustion. So C2H6, hopefully you remember that's a hydrocarbon. In combustion it's going to be hydrocarbon plus oxygen, yields carbon dioxide and water. And then we're going to have to balance this thing. I can look ahead and see if I put a 3 over here, that's going to give me an odd number of oxygens. So I'm going to do a double here, and that will have me put a 6 here, which will give me an even number of oxygens. Also, let's balance the carbons, and then I think that'll be a 7 to balance that out. So that will provide me with some much needed information. Okay, you always start with the known on these problems, just like in the mole unit, and when we initially learned dimensional analysis. So we'll start out with 5.03 grams of C2H6. Then we're going to convert our grams to moles. So 1 mole, use molar mass to do that, C2H6. And let's add up the molar mass of C2H6 using our reference table. Alright, so I added up the mass of 2 carbons and 6 hydrogens, and I got 30.0068 grams. Alright, so far so good. Let's check. So we canceled out our grams of C2H6. Now we need to go moles to moles. So we're going to go moles of C2H6 to moles of CO2. And in order to do that, we're going to use the balanced chemical equation. And let's see, we need this one, and we need this one. Okay, so it's going to be 2 moles of C2H6 on the bottom, and it's going to be 4 moles of CO2 on the top. Alright, and let's cancel out units as appropriate here. So the moles of C2H6 will cancel out, and then we just need to go to grams of CO2. Alright, so in 1 mole of CO2, let's add up the mass. It's 44.01 grams when you add up the 1 carbon and 2 oxygens. Alright, and we'll cancel out our units there. So the moles of carbon dioxide cancel out, and then we'll plug that into our calculator. So I'll probably put this in the calculator, 5.03 times 1 times 4 times 44.01 divided by parentheses 30.068 times 2 times 1 in parentheses. Or you could just multiply everything on top, multiply everything on the bottom, divide the top by the bottom. When I carried this out, I got 14.72, which I'm just going to round to 14.7 to match the 3 significant figures of the known. So that is going to be grams of CO2. Alright. This next problem is a similar example, so maybe pause the video, give it a try yourself, and then watch my solution to it. So silver nitrate reacts with excess sodium chloride. Calculate the mass of the silver nitrate required to produce 3.60 grams of silver chloride. So let's set it up. So our unknown here is the mass of silver nitrate, so grams of AgNO3, and our known is that we have 3.60 grams of silver chloride, or we're going to make 3.60 grams of silver chloride. All right, and our plan, well, two different compounds here, so we're going to have a chemical reaction to convert, so balanced chemical equation. All right, and then we're going to go grams to moles to moles to grams. 3 steps, again, very similar to the last problem. All right, and then the solve, let's write the chemical reaction up here. So it says silver nitrate, AgNO3. All these are +1 or -1 charges, fortunately. That makes it easy to write the formulas. Okay, and sodium chloride. For face-to-face in class, we would certainly do a demo of that so you could see it. And then that's going to make AgCl and NaNO3. All right, and you know, when you balance this thing, well, they're all ones, so the mole ratio here will just be a 1-to-1 ratio. Anyways, let's work our way through this problem. So we'll start with the known, like always, 3.60 grams of silver chloride. To get the moles of silver chloride, by the way, folks, please write out the compound so you don't get lost, and so I can actually follow your work and figure out what you were doing. All right, so we need to add up our molar mass of the silver chloride. Added that up, and I got the mass of silver chloride is 143.32 grams in 1 mole of AgCl. All right, now the mole ratio here, we're going from silver chloride to silver nitrate, so we need this one, not that it matters, and that one. And the reason why I say it doesn't matter is they're all 1-to-1, so it's pretty hard to mess this one up. Alright, so let's plug that in. 1 mole of AgCl, because we want to cancel that out. And then we're going to make 1 mole of AgNO3. Or actually, we're going to need 1 mole of AgNO3, because it's a reactant. Cool. So let's go through and cancel some units here. So and that leaves us over here where we have one more step. So we need to go from moles of silver nitrate to grams of silver nitrate. So we need to add up the molar mass of silver nitrate. I got 169.88 when I added that up. So at this point, we'll put that in the calculator, multiply everything on the top, multiply everything on the bottom, divide the number on the top by the number on the bottom. All right, when I carried that out, I got 4.267, which I'll round up to 4.27 grams to have 3 significant figures to match the known, and that's going to be silver nitrate, AgNO3. And just to be consistent here, let's cancel out our moles here so you can see that. All right, one more example problem. So this one asks us to, oh yeah, let's box in the answer. There we go. Okay, so let's calculate the mass of calcium chlorate needed to produce 3 liters of oxygen gas. Now, here would be a good place to draw your attention to a resource in Canvas that is really good. I draw something like this It's basically another version of the mole map. It shows you how to navigate here. If you got volume or grams and mass or even particles. So always go to moles, use the coefficients from the balanced chemical equation to do the mole conversion, and then the moles that you're finding, then you can go back to volume or mass or particles. And notice that, you know, if you're doing volume, for gases at standard temperature and pressure, you can do 1 mole equals 22.4 liters, molar mass when you're going to grams, and then Avogadro's number if you're going to or from particles or ions or formula units or molecules or ions. So let's go back to the problem. All right, let's set it up. All right, so the unknown is the mass of calcium chlorate you need. All right, the known is the 3 liters of oxygen gas. The plan is we are going to go liters to moles. Probably always going to be your first step unless you're already at moles. And then we're going to go from moles of oxygen to moles of calcium chlorate. And then we're going to go from moles of calcium chlorate to grams of calcium chlorate. Oh, and I forgot something. We start with one thing, we go to another, so that means we need a balanced chemical equation. All right, so we'll solve down here, but we'll write the equation up here. Okay, so we're producing oxygen gas. It says calculate the mass of calcium chlorate required. Required, that sounds like you're starting with it, so that would be a reactant. CaClO3, 2. And it seems like that this could be the decomposition of a metal chlorate. So that means that it's going to make oxygen and a metal chloride if you look back at page 6 of your reference table under the decomposition types. So the metal chloride here would be CaCl2. Now, we do need to balance this, so we'll have the right coefficients. So let us do that now. Let's see, so we've got 6 oxygens here, so we could put a 3 there, and that would balance that. And you know what? It looks like that's all it needs because there's 2 chlorines and 1 calcium, and that's true on both sides. So, you know, you could just throw some 1s in there if you really wanted to. Don't have to. I probably wouldn't if I wasn't doing this for the mole ratio to show you, but let's go. Okay, so we're going to start with the known, 3.00 liters of oxygen. So I should have said this here on the problem, but the assumption here, yes, this is at standard temperature and pressure. Only works for gases, but it does tell you it's oxygen gas. There's no way you could solve this problem if it wasn't at standard temperature and pressure, or you didn't know what the pressure and the temperature were. So there you go. So we're going to use that, and so 22.4 liters of oxygen equals 1 mole of oxygen. Then we're going to do our mole conversion. So we need oxygen and we need calcium chlorate. So it's going to be 3 moles of oxygen and 1 mole of calcium chlorate. And then our last step is we got to get back to grams of calcium chlorate, or get 2 grams of calcium chlorate. So that's going to be a molar mass thing. So we got to add up the mass of the calcium chlorate. So let's do that. Alright, so I got 206.98 grams of calcium chlorate. Then I plugged in my entire calculation into the calculator just to point out all these units do cancel out. And my final answer came out to be 9.24 grams of calcium chlorate. So it doesn't take a lot of a solid to make a lot of a gas, because gases are much less dense than solids. Thanks for watching.